Good afternoon, everyone. It has been a long time since we met in this way. It's just a day, but it feels much longer than that, isn't it? Anyway, so I hope you all had lunch, and we will be doing this is going to be a slightly shorter session. We will do almost 2 hours, mainly because of the nature of the topic. So the main topic for this session is futuristic. What are the opportunities and challenges that we have in using AI for condition monitoring? Okay. So how many of you here had a chance to see the demo yesterday, like in the Center of Excellence, when the gentleman showed vibration? So everyone? Probably you too did not see it. Okay. Okay, so that is good. So that will help in this activity. Anyway, so the outline, I have 3 major bullets in the outline. The first one is an announcements, couple of announcements I have, and they are reasonably significant. And then there is a quick review where you will be helping me recollect what ANN is all about and what so that is the idea. And then we will dive into opportunities and challenges. And because this is a session after lunch, this is the most difficult session to instruct, especially when we have some excellent food provided by the guest house. So what I am planning is to make you all work in smaller groups, not by sitting but by standing. Okay, and that is why we brought a couple of boards. So we will have, and we will also practice presentations at the end of this session. So anybody who is into PhD or masters, they will be given preference for presentations. Teachers will be taken back seat because they always love to talk. I am like that. And then students will be given preference. Okay. First announcement is about publication avenues. So this came up while I was talking with a few of you yesterday, and then I realized that so for the field like condition monitoring, there are a few good avenues that you can explore publications. There are definitely journals and transactions and magazines, but I am focusing on conferences. So there is a conference called IEEE Transportation Electrification Conference, and this is a conference that happens around the world, region specific. So there will be one conducted in North America, one in Europe, one in Asia Pacific. So the Asia Pacific one is the one I am presenting here, and this year it's happening in Singapore between 25th and 28th November. Okay, if I'm not wrong, you still have the call for papers open. I hope many of you would be considering to submit your work if you are at that stage. I mean, if you are in the initial stage, then it might be challenging, but if you have some progress done already, then this is a great opportunity. The second conference, which is exclusively on diagnostics, is a conference that's very popular. The only drawback of this is held typically in North America or in Europe only. Okay, so this is a little bit of travel for you. But if I can come all the way from Vancouver to India, you can come all the way from India to the US, right? There is nothing. It's just it's up to you to decide. So this year it's happening in Dallas in the USA, and this is a conference which is considered of high regard in our field, in this field of research. So if you want to establish yourself in this field of research, then this is an avenue that you should consider actively. And just for your information, if you go to any of these conferences, they are reasonably big, so upwards of 1,000 participants. So you will have lots of opportunities to initiate interactions. Attending such conferences also will need a lot of preparation. Other than technical preparation, you have to identify whom you need to talk to, because when you have thousands of people, you may not be able to talk to everyone, right? So you have to prepare ahead of time which person, which group you need to talk to, etc. The last conference I want to talk is about the Energy Conversion Congress and Exposition. This is a big conference as well. This also happens region-wise. I'm not too sure if it is There's one Asia Pacific maybe, ECCE. But I am focusing on the North American edition of it. This year it's happening in Philadelphia, but the reason why I brought this up is because in 2026 it is happening in Vancouver. So that is closer to where I come from. Okay? So I have given you enough advance notice or invitation, however you want to think, and I expect you all to be there in 2026. Okay? So this is also a massive conference, upwards of 2,000, 3,000 people typically. So it's a very big conference. But because it's going to happen in Vancouver, and typically it happens in fall, autumn season, October. And that's a nice time to travel. Okay. So this is the first set of announcement I have. These are just 3 conferences I'm presenting. There are many more, but especially the second one is something quite relevant. The first one I thought is something very soon, and it's close by, so you can explore. And the last one is simply because it's happening in Vancouver in 2026. Okay. Then the more important announcement, now that we have come to the 4th day of the workshop, tomorrow is the day when we will have our exams. So there is an exam for this course too, because all these days you have been happy, right? So we have to do something to change that. I do not know why my animation is all the upwards. There will be an examination tomorrow. The exam will constitute a portion of the course grade. The lecture, attendance, labs and demonstration, they are all part of the course grade. Okay, so you will be given a pass or fail grade, if I am not wrong, by the end of the workshop or the course. The exam will be a written exam, so you will be having some time, given some time questions, and you will be expected to write answers. The questions will be numerical type as well as conceptual type. So when I say numerical type, you can, so we have discussed 3 algorithms so far, KNN, PCA, and basics of ANN, right? So you can expect questions on these 3 algorithms. So I will give you a data set. I will ask you to find the nearest neighbor. Okay. I will give you a data set. I will ask you to find the principal component. I will ask you a network, a neural network, and I will ask you to calculate the prediction at the end of first forward pass. Or I will ask you to calculate the rate of loss, change of loss function with respect to weights, dou J by dou W, like that. Okay, so these are typical numerical examples. The size of the numerical problem will not be massive, as if in a real world machine learning. This is a pen and paper exam, so it will be more manageable. But you will be still expected to do some calculations. So please bring your calculators if you have. Otherwise, you may have to use your cell phone. Okay. So if this has already scared you, I have something that will calm you down. You can refer to resources during the exam. It's not going to be, because it's just a short-term course. I don't expect you all to have, remember things. But the only constraint you have is you can only refer. You cannot ask for an answer from another entity. When I say entity, this is now taking different dimensions. So usually we say don't discuss with people, right? But nowadays there is much more than people that is available out there. So you are not expected, you are not supposed to take help from any entity. Okay. So that is the restriction you have. If I do not know exactly where the exam will happen, but it will happen tomorrow after lunch. So the logistics sirs will coordinate. And, it will be a straightforward exam. It will be nothing beyond what you know and what you have discussing. It will be an MCQ. So the questions will have few options, but say for example a numerical problem, but there will be 4 options. And if there is an MCQ, then always we will have negative marks, right? That's the standard, right? No negative marks? Okay, no negative marks. Okay, so you'll just have either 1 or 0. It will make life easy for grading actually. If I have negative marks, then it makes my life difficult. Anyway, so these are the two major announcements. Any questions at this point about the exams? Yes, sir. We have been sharing materials. So I will share the slides as well via WhatsApp. I mean, my slides are all blank slides, so I don't know how much it will be useful, but still, I will share the annotated slides, okay? So that the MMF permeance analysis can be a one question. Okay, anyways. Okay, so these are the announcements. Is there any questions for me at this point, or shall we continue? Good? Okay, fine. So we are going to talk about opportunities and challenges. So I want to show you two images. It's the same space. So these are the opportunities you have. You may have to overcome some challenges. So do you understand what this is? Snow, okay. So this is how the campus was when I left for the workshop. So 1 week ago, this is how it was. So I'm not complaining about the heat here. At least not yet. Anyway, so first thing we will do is we'll do a quick recollection of the ANN procedure. The general, basic procedure that we discussed. I know you all had lunch, so I'm going to let each one say one thing about the procedure, okay? So we are going to start any random place. Anybody can go first. Whoever wants to go first can go first. And then I will jot down whatever you say, and then we will rearrange to put it in a sequence after everybody has mentioned, okay? So what I want you to say is, what are the steps involved in, let's say, if you want to perform machine learning or using artificial neural network? What are the steps involved? Okay, so whoever wants to go first, please raise your hand. Okay, so we will go with that person first. So I see Swapna madam raising her hand. Please. Did I say your name wrong or correct? Okay, that's good. So one step, any one step. It doesn't have to be in the sequence. Collecting the input data. Okay, this is a very loaded word. Collecting the input data. So we will discuss this later on. Okay. Next, another person, maybe. Initialize weights. Okay, wonderful. Everybody will get a chance, so don't worry.
Train the system. 70% data used to train the system.
Okay, so create a training set. Or train the model. So you are saying train the model. Okay. Train the model. Okay. Yeah. Extract features from raw data. Okay. Selecting hyperparameters. Let me just check. Okay. Number 5, selecting hyperparameters. Can you name any hyperparameters? Like not you, but anybody? Like any of the hyperparameters? Do you remember? Number of neurons in the, so basically size of the layers, number of layers, all those things. Okay, that's good. Good. So you all remember that. Wonderful. Yeah, please. Okay, so create a network is what you are saying. Yeah, create a network. So I'll put it that way. Okay, so I'm just rephrasing what you are. A neural network by setting the parameters. Basically, how many neurons should be there? What are the defining the input layer, defining the output layer, all those things. Okay, that's good. Calculating the loss. Okay. Calculating the loss. Loss. Okay. Deciding on activation function. Wonderful. Does anybody remember the activation functions, some of them? Okay. Okay. Okay, thank you. Thank you. Deciding the activation function. So what I can understand is you all are having much better memory than I do. Deciding the activation function. Who has to go next? Devdarshan sir? If you want time, you can take some time. It's up to you. Okay. Okay. Error calculation? Okay. I think the error calculation is already mentioned, but okay. So I will just write optimization algorithm, and we will algorithm. I will write error calculation for the time being, and then we will discuss this. I thought you already spoke, right? No? You did not say anything yet? Okay. Regularization. Okay, wonderful. Regularization weight or regularization formula and choosing regularization equation and its appropriate weight. Regularization. Does anybody remember why we do regularization? Or why is it important in ANN? To avoid or to mitigate the chances of model getting overfitted. Okay? Yes, sir. Back propagation. So, okay, so that's a term. Yeah, we will come back for second round later, but we'll first finish to creating confusion matrix. Wonderful. Confusion matrix. Okay, that's nice. So maybe few last. Anybody else that is yet to speak? Forward pass. Okay. Back propagation. Forward pass. So there. So these are terminologies that are not necessarily like the steps. They are part of activation function is already mentioned. So we have that. Deciding the activation function. So that is also there. So I think, so calculating loss is just calculating J, loss. What we need to do is we need to find the change of loss with respect to weights, right? So dou J by dou W and update the weights. So that is back propagation. So that is what we are doing here. Okay. So if, I mean, all the steps are captured, just that the sequence might be out here. Usually we will collect, when we say input data, it's a little bit misleading. So we will collect data from environment, from a physical environment. So it is usually not necessarily the data that we will feed into that ANN model. It can be, but it is not guaranteed. So we can call this as raw data. Okay. Extract features from raw data is good, but it misses one step. You need to do data processing before you can extract features. So what is data processing? Say normalization or eliminating noise, some of the things. Okay, so they are, so usually when you want to extract features, before that you do data pre-processing or data processing. Okay, and then you extract features. Okay, once you have extracted features, that is your data set. Then you will split it into training set, validation set. Okay, so once you have the training set and validation set, you will select the hyperparameters. You will create a network. And then you will initialize weights and bias. Then you will calculate the loss through a forward pass. So this is basically forward pass. Okay, so you will, so the activation function will be decided when you create the network. Then you will do a back propagation to calculate the change, but you would have decided the optimization algorithm. I don't know what one of you meant by error calculation. Maybe it's same as the loss function. I'm not too sure. Maybe it is. I'm not too sure. Then you will also, in the loss function or in the cost function, you will add a regularization with a weight so that you can avoid overfitting. Okay. Then once we have done that, so this is just one loop. So we have done one epoch, right? And then we repeat it multiple times until our loss function goes down in value, and then we get a good prediction accuracy. Then we stop, we use that model, we use validation set to check the accuracy. Once we are happy with the accuracy with validation data set, then we deploy the model for actual field testing. Okay? So we are all able to recollect the methods, so that's good. So overall, I can say like this. Some of the steps involved include data collection, data processing, feature extraction, and then choosing the network, basically choosing hyperparameters. Defining the network basically, and then training training comprises of the whole process, calculating the loss, optimizing it, all those things. But once training is done, when we have reasonable, acceptable accuracy, what we will do is we will capture the time taken for training, time taken. We will also make a note of the computational resources needed to carry out this training. Okay. And then we will test the trained model with validation data set. We will check its accuracy. So basically, training will result in some accuracy or performance parameter, training time, and training computational cost. So there are three things. One is training accuracy, which is the performance. So training performance, training time, and training cost. So these are the three things we will record. Then we will subject the trained model with validation data set. For the validation data set, we will check what is the accuracy or performance, what is the time, what is the computational cost. Okay, so these we will record that. Typically, validation performance would be either equal to or worse than the training performance. Okay, that is the general expectation. So is this clear? Then finally, we will deploy the model, and we can say with some degree of confidence that this is the percentage accuracy we hope to get when given an unknown data. Okay, so now that I have spoken a lot, I should break things up. So we are going to do an individual activity now first. So this individual activity is a quiet activity. That means you cannot talk to anyone, but you are supposed to take a piece of paper and pen. And what you are going to do is, the major purpose of running such Gyan workshops is, of course, to introduce you to newer topics, to get you started or to help you go one level up. But the major purpose, the overall goal, is to inspire you to pursue activities in this field. Okay? And I am a very confident, positive looking person, so I believe that I have already inspired you all, that come Saturday, you are all going to start your work in this field. Okay? So that is my belief. I may be wrong, I may be right, only time will tell that. But with that belief, if you all decide to carry out research in this field, so this is an individual activity, you are going to imagine that there is no one else around you, just you. What challenges do you foresee from your perspective, okay, if you have to carry out this research in this field, or if you have to pursue this future, what challenges do you foresee that might inhibit, that might stop, that might obstruct you from proceeding? Okay? So what I want you to do is take a piece of paper, pen, whatever you think, jot it down. How about 5 minutes? Okay? 5 minutes. So from your position, so if you are working for an institution, then from that setting, from that environment, what is the limiting factor? If you are a student, what is the limiting factor? So put yourself in your current environment and then write down the challenges. Okay? 5 minutes. Does everyone have paper and pen? Okay. Anybody needs paper and pen? Okay. So there is no right or wrong in this exercise. Whatever you think is going to prevent you from carrying out research in this field, put that down. Okay, that's the whole thing. It's your perspective, your view of what you believe might be obstructing or stopping you from doing this. So we have 1 more minute, and then we are going to do another follow-up activity. Okay, so 1 more minute. It's time, so you can stop writing. And I see that we have almost a 50-50 split between students versus non-students. So that's very good, because the next activity is what I call as a pair and share activity. But you are now going to relinquish the comfort of your seats, and you are going to pair up with, so if you are a working professional, you are going to pair up with a student. Okay? Vice versa. So no two students or no two working professionals going to be in the same pair. Okay? I think one group might have, one or two groups might have 3 members, but that is how we are going to do. Okay? So you can stand, pair up, spread out, and then what you are going to do is each of you is going to exchange at least one topmost challenge in their mind that might prevent them from pursuing this research activity. Okay? So if there are 2 people, each one exchange the topmost challenge first. Then if there is still time, they go to the second challenge. Okay? So you will again have 7 minutes, okay, to do that. So 1 minute to pair up, and then 5 to 6 minutes to chat. Okay? So no 2 working professionals can be in the same team. So each one has to identify a student, and then we are going to pair up. Okay? So quick. You are going to discuss, so please spread out as much as possible so that you are not interfering with another group's discussion. You have this is a reasonably big space, so you can always move around. And
ఫ్యూచర్ ఎలక్ట్రికల్ మిషన్స్ చాలా ఉన్నాయి. సో ప్రతి మిషన్స్లో అప్లై చేస్తే మనకి వెహికల్స్ కానీ ప్రతి అప్లికేషన్స్ మిషన్ అనేది జనరేటర్లో అయినా మోటార్లో అయినా ఇన్వెన్స్ అనేది వాడుతూనే ఉంటారు. Next, as a faculty, to create a course for curriculum add చేయాలి. curriculum classes labs course అనేది create చేయాలి. నేను రాశాను as a faculty. Next, hardware skills. హార్డ్వేర్ సెటప్ హార్డ్వేర్ డెవలపర్స్ తీసుకొచ్చి దాని మీద కూడా స్కిల్స్ వాళ్ళకి ట్రైన్ చేయడానికి యాజ్ ఎ ఫ్యాకల్టీకి లెర్నింగ్ నేర్చుకోవాలి. డెఫినెట్గా ఇది చేయాలి అని అయితే అది చేయాలి. రైటింగ్ ఫస్ట్ పాయింట్ అది. ఇది పర్పస్ లెర్నింగ్ ఈ ఆబ్జెక్టివ్ ఈ పాయింట్ ఫస్ట్ పాయింట్ అంటే అప్లై చేస్తాం. కోర్స్ అనేది ఏమీ తెలియదు. కోర్స్ ఎలా క్రియేట్ చేస్తాం, కోర్స్ అవుట్కమ్ ఏంటి, అవుట్కమ్ బట్టి కోర్స్ మనం డిజైన్ చేస్తాం. అక్కడ ఏంటంటే ఫ్యూచర్ మిషన్స్ ఇది నాన్ ఇన్వెన్స్ ఎలా ఉంటుందని తెలుసుకోవడం కోసం మనం ఈ ప్రొసీజర్ ఫాలో చేయాలి. స్టూడెంట్కి అది చెప్తాం. దీనికి మ్యాచ్ చేస్తాం. మీరు ఏమైనా దీనికి ఈజీగా రాస్తారు. అది రాసేయచ్చు. ఫస్ట్ పాయింట్ ఈ పాయింట్ రాయండి. ఫ్యూచర్ ఎలక్ట్రికల్ మిషన్ దానికోసం స్టెప్స్ ఏంటి మీరు రాశారు. ఫాల్ట్స్ ఏంటి ఫాల్ట్స్ అంటే అన్నీ ఇస్తారు. ఎస్సీ వస్తుంది, ఈ వస్తుంది. సెన్సర్స్ పెడితే ఏది మాట్లాడితే చెప్పారు. సెన్సర్ పెట్టలేము. ఇన్వెన్సివ్ అంటే సెన్సర్స్ నాన్ ఇన్వెన్సివ్
ఇన్సైడ్
ఇన్సైడ్
మనకి
సెన్సర్
ఇన్సైడ్
నాన్ ఇన్వెన్సివ్ అంటే వచ్చే అవుట్పుట్ బట్టి మనం ఐడెంటిఫై చేయడం. ఈ మెథడ్ యూజ్ చేసి ఐడెంటిఫై చేయడం.
మెషిన్స్
ఫర్ ఫ్యూచర్ ఎలక్ట్రికల్ మిషన్స్ మనం ఫ్యూచర్లో ఏం యూజ్ చేస్తాం కదా, ఫ్యూచర్ ఎలక్ట్రికల్ మిషన్ అప్లికేషన్స్ అని రాస్తారు.
సైడ్ కూడా మనం యూజ్ చేసుకోవాలి.
ఫ్యూచర్ అప్లియన్సెస్ అన్న
ఈవీస్ అన్లోడ్ చేస్తాం.
ఫస్ట్ మిషన్లో నార్మల్ మెషిన్స్ తెలుసుకొని నెక్స్ట్ ఈవీ సైడ్
నా పాయింట్ ఏంటంటే ఈ ఫ్యూచర్ ఎలక్ట్రికల్ వెహికల్స్ మిషన్స్ అంటే నా దగ్గర 10 స్టూడెంట్స్ ఉంటారు. నేను ఒక్కొక్కరికి ఒక్కొక్క అప్లికేషన్ ఇస్తాను. మీ పాయింట్ ఏంటంటే మీరు పర్టికులర్గానే చేద్దాం. నా పాయింట్ ఆఫ్ వ్యూ
ఒకవేళ మనం ఈవీ సైడ్ అప్లికేషన్స్ తీసుకున్నప్పుడు ఈ టెక్నిక్ మనం
అన్నిటికీ అప్లై చేసుకోవాలి. అంటే ఫ్యూచర్ అప్లై చేయాలంటే ఫస్ట్ ఏంటంటే నేర్చుకోవాలి. సాఫ్ట్వేర్ నేర్చుకోవాలి, సాఫ్ట్వేర్ నేర్చుకోవాలి. ఆ ఫీల్డ్లో పర్టికులర్గా అది వచ్చి ఛాలెంజ్ కదా.
How are you doing on time? You need some more time or you are done? One more minute, maybe one more minute? One more minute? Okay, one more minute.
నా పాయింట్ ఆఫ్ వ్యూ లాస్ట్ బటన్స్ ప్రాసెసింగ్
Okay, so I think thanks for the active discussions. So now I am going to take your help in summarizing the challenges that you have identified. That is what I am going to do. I am going to write down the challenges. So what I want you to do is to share at least one challenge. Each group is going to share one challenge. And because I foresee many of them would be similar, so that's why we are going to go around. And then if there is still some more things to add, then you can share. Okay. So we'll start from the rightmost group. So please, one challenge that you have identified. Sir, can you please repeat?
Lack of knowledge and coding and software tools.
So knowledge gap. Okay. Thank you so much. So next group,
Yeah, that is we want an experimental setup for collecting the real-time data or machine data.
okay. So, lack of facility for real data. No? Okay, lack of facility for experimental data. Okay. Okay, thank you. Third group.
Model design. Application model design.
Can you please
You don't
elaborate?
have that knowledge. How you implement the application oriented model?
Application oriented. We have knowledge in some case, but we require the knowledge in all the three. That means if we need to have efficiency on coding, the same way our application will spread out.
So, in some sense, it's knowledge gap.
Knowledge.
Okay. Any other challenge that you have thought of?
I think we discussed about
These two.
First and second.
First things. Okay, that's fine. That's fine.
Same knowledge.
That's fine. That's okay. That's the idea.
Lack of knowledge in hardware and software, like that we will.
Okay. So knowledge gap in hardware.
Hardware and software.
The compatible models. Compatible models. Compatible.
Compatible models. So you want to know which one
Which one is suitable for this
suitable.
application?
Those kind of details. Like when you say knowledge gap, it's like the details, not the top
based
level.
on
Details. In depth. Yeah, that's understandable. Okay. Time.
Time management.
Time and resource constraint.
Time management.
Okay.
Expert for creating experimental fault or setup. Expert requirement required. Expertise.
Expert delivery.
Creating experimental setup. Yes. So the group that mentioned about the lack of facility for experimental data, right? Okay. So anyone else wants to? Anyone can add now. So now that everybody has taken one chance. Problem identification. So within this realm of monitoring for propulsion motors, what specifically would you want to work on, right? So problem narrowing down the focus, so kind of problem identification. Okay, I do not know if this is okay. Next one, anything else? Cost. Cost and practicality. What do you mean by practicality?
It is real time how well it works. It is actually, for example, some electric vehicle application. How this will suit for in person, because the overall cost is going to be huge for now doing this research implementation.
Okay, so practicality from implementation perspective.
Financial matter.
Okay, cost is a constraint.
Yes, cost.
Should be a constraint. Otherwise, we won't do well. Anything else that you want to add?
So, actually, that
Let's
mathematics aspect, means algorithm if you are trying to do, if you are using machine learning algorithms, then maths behind that. Otherwise, conceptual behind that. For example, you can an algorithm or
Knowledge only.
Somewhere here. I will do it somewhere here.
Yes. Knowledge.
Okay. So these are the challenges mostly. Okay. It's good. These are the challenges that you have identified, right? What I'm going to do is I'm going to let them be as they are for the time being. We will discuss them in a few minutes. But let us recollect the steps involved in implementing, say, in an algorithm, and let us see if you can come up with identifying any challenge in each step of the way. Okay. So it can be a knowledge gap. For example, I will give you an example. So step 1, data collection. What challenges do you foresee here? So for example, you have mentioned lack of facility for experimental data set. And then expertise to create experimental setup. Okay, so these are all challenges that will impede data collection, right? And also cost. Sometimes you may not have the budget.
Because we are creating a failure. So we have to create the model such that multiple times I have to make the fault and I have to get the data collected.
So you have to create a failure, but which is still safe, right? So you have to, yeah. So that is the first step in implementing machine learning model requires data collection, and in order to collect data, you cost prohibitive for setting up experimental work, or experimental test bench is expensive. And then expertise, okay, cost, expertise, okay, even expertise in creating this, okay, expertise required. Okay, for the time being, let us assume that these two constraints are not there. Okay, so this is what I'm going to do. I'm going to say every challenge is not there. Assume, like how you did 4 equations is 2 equations, right? So I'm repeating what you did. Anyway, so assume that the experimental facility is available and you have the expertise needed to create that setup, make it work in a safe manner. And for the time being, let's even say cost is not a major constraint. Okay? Do you still foresee any problem with data collection?
Practical field, laboratory, that can be discussed.
Okay, so data collection, these are definitely constraints, challenges, but even if you can overcome them, what challenges do we have? The collection of data itself might not be as accurate to a practical or a real world situation. For those of you that attended the demonstration yesterday, for a lab grade motor with an high accurate sensor, we were having lots of challenges, right? So positioning of the sensor, making sure it works fine, and so between healthy case and faulty case, the sensor must be in the same position to ensure that this vibrations have been picked up at the same point, right? And so there are many challenges even if you have an experimental test bench while you collect data, right? So what I want you to focus on for briefly right now is, okay, these challenges will definitely exist, but if you assume them to not exist, even if you have access, say for example, tomorrow I invite you to my research lab and I give you all the facilities, what challenges do you still have is the quality of data collection, data collected, comparing it with a real world situation. So can you collect similar data from real world versus the data that you can collect from a lab environment? Or how close to real world situation can your lab experimental test bench be when it comes to data collection? Okay, so from a propulsion motor perspective, let me give you a clearer picture. So in all the examples that I presented with experimental data set, I said I collected 15 seconds of data, right? How easy do you think would it be to collect 15 seconds of steady state current data from a motor that is being used in an electric vehicle? So what is 15 seconds of steady state data from a lab environment? My motor speed, my motor load are constant. Right? Am I correct? That is what we are as steady state condition means for us. I have collected 15 seconds of data. In a practical environment, if I have to collect the data from a propulsion motor of an electric two-wheeler or a passenger car, how easy would it be to do that equivalent data collection? 15 seconds of steady state condition. What is your expectation? Like, do you think it would be consistent, or do you think there will be already some variation either in speed or in load? Some variations will be there. So now what we have is, we do not know how much time we will have to acquire data. So basically we are going to collect data. Let's say if we collect for 30 seconds, it is not steady state anymore. Or over that window, it is not one steady state. It is multiple steady states probably, and some transients. So we have never explored that even at the lab setting, right? So now even if you have the experimental test bench, you may not have a data collected which simulates real world. So when you have an experimental test bench, it is important for you to ensure you are collecting data in a manner that is as close to real world as possible. For example, the demonstration that we saw yesterday, the motor was mounted on a rigid frame, but it was not bolted to the table. If you go to any industry, that is not going to be the case, right? You will never see a motor just by itself. I mean, in some applications you may see in some sites, but in a factory setting, in field, that is not the case. It's rigidly secured. So when you collect data, even if you have a test bench, it is absolutely important to collect data which is as close to real world as possible. Otherwise, no matter how expensive equipment you have invested in, your model is not going to be implementable at the end of the day. That was one of the challenges you said, right? So this is one aspect. How about certain parameters in data collection, like sampling frequency? How do you know what is appropriate? So if you have an inverter driven motor, if the inverter is being switched at, let's say, 4 kilohertz, what should be your sampling frequency? How would you filter out the signal? Okay? So these kind of technical challenges exist in the first step, data collection. Right? So this is the first step, and we have some challenges identified, technical challenges. So next step is data processing. So the vibration sensor is a great example that we could see yesterday. When we collected data from it, there was not just vibration, there was a lot of noise. So we have to do signal processing right at the front end without eliminating the signals of interest. So what does that mean? Our sensor should be having high signal to noise ratio, and our algorithm should be good enough to extract the required signals. Filtering. Okay. So as I say, probably your knowledge gap challenge is widening. Right? That is only thing that you could see as an individual. Okay? We will come to that in a moment. So in data processing stage, we have some problem. Okay? How easy it is to get high frequency data, like high frequency sampled data in an actual setting. For example, in a motor used in a plant, is it easy to get, let's say, 3600 hertz sampled line current data? Or what kind of data is easy to get? Can you get RMS current, or can you get sampled current? Which is easier? RMS current. So the real world data set might be in a very different form than what you might be collecting. And so your data that you are collecting in the lab and the processing you are doing might not be even realistic. Okay? So you have to think from that perspective. So the next step is our favorite. Feature extraction. Assume you have collected good quality raw data. What features would you extract out of it? How would you know that? How to select features? So you can try different things, but there is only trial, right? You are trying different things based on literature. So how to decide this? So this is again the knowledge gap that some of you are mentioning, the depth that we might not be having at this stage. How to decide. As I said, once we are converting or treating everything as data, we don't have to worry about the physical meaning, right? We can add voltage signal with current signal. We can manipulate it in many ways. So features can also be of infinite order then. So how many dimensional features we need to choose, we do not know. Whether we should have 2 features or 200 features, we have no answer. Right? So the first 3 steps of any machine learning model are these. And we already have identified technical challenges that are so many. Then if you go into a specific model like ANN, obviously you have technical challenges like choosing hyperparameters. You can do, how do you set the layer size? How do you decide on the number of layers? Okay, so there are many questions. What is the computational resource you have access to? Do you have a high-end computer? Do you have just a microprocessor? What is that you are planning to work with? Right? So there are many things that you will have to look at. So all I am trying to say is these challenges that you identified are very much real. They are real. They exist. I am not saying no. But even if you overcome some of your identified challenges, the problem does not end there. The problem starts there. Okay? So money is a challenge, but you can go on fundraising. You can get funds. Okay? You can raise funds. But if you have money alone, you may not be able to address technical challenges. So the knowledge gap is the biggest problem we may have to encounter, address at this point in time. So what I'm trying to say is, if you think about the steps involved in machine learning, there are 4 major steps. And in each step, we have challenges, technically speaking. Okay? So I would be not utilizing this opportunity because all these challenges are real and existing, and I'm also facing them. So I would be wasting a great opportunity to identify the solutions if I leave you today. So what I'm going to do is I'm going to take your help, and I'm going to make you, so you are nicely seated, so you're going to go into 2 groups, one on my right, one on the left, and you now know some of the technical challenges. Okay, so don't worry about the non-technical challenges like time, cost, all those things, but think from the technical challenges. So I will restrict because there are only 2 groups. So what I'm going to do is I'm going to give you some time. So one of you is going to focus on data collection, like quality, real world like data collection. That is the technical challenge. I want one group to identify, brainstorm, and come up with solutions. Okay? So what you are going to do is you are 7 people. You 7 have come up with some ideas. In what way you think, it may not be even feasible, that is okay. We are looking into the future now. So we are looking at the opportunities now. So what way you think can these challenges be addressed? So the challenge that you are going to work with is how to get high quality data, assuming you remove the constraints like experimental setups, availability, cost, all those things. How can you get high quality data? Okay? Simulating the real world. And on this side, you are going to look at the problem of feature extraction. So how can you address this problem? When you have data, what is the best way to address the feature extraction problem? Okay? So what I want you to do is go into a group. You are welcome to look up internet, search, okay, all those things. So it's 3:40 almost. So we are going to give you 10 minutes, 10 to 12 minutes each group. Identify, and then there will be 2 whiteboards. So once you have identified, at the 15th minute mark, I will invite one of you to come and write down some of the solutions you have identified. Okay? And then we will reconvene. So 12 minutes for discussion, 3 minutes for writing. So 15 minutes activity. Is that clear? So it's just brainstorming. You are going to come up with some solutions for this problem. And I am going to take picture of these solutions and go back happily. Okay, so you can get started.
Yeah, some
So ours data collection, they are dealing with the features.
Come up with some ideas
How to quality
as close to real world as possible, right? That's the problem we need to identify. So how can we address that? That is the so think of ways that in your mind might be working. It is okay even if they are not practical or realizable at this stage. So all the things brainstorming first, so that means whatever comes to your mind versus speaking out, and then after 10 minutes you decide as a group, okay, this makes more sense, this is more realistic, then you will write it down. There's a marker that is on the back side, so you can use it. Okay. Quietly brainstorming or you're doing research first and then
We are actually warming up our minds. Like we are like behaving like induction motor, so it's getting time.
starting time is
Starting time. So
starting.
It's
No,
starting
initial
problem.
current.
So this year,
I should add no resistance in the rotor flow.
yes, sir, like that we are.
Okay. So
capacitor is not working. Capacitor started motor, capacitor is not working.
So that's for
Induction motor. No.
some ideas first, then do research, then think. Okay. We have some ideas.
like what I experienced in my laboratory. So we have to extract this practical laboratory input very variety of the conditions. So like maybe maybe people are testing for something else. So but however, it should be even more than that, like loaded case, even it's even more than that. Loading is very much one.
How to bring it back again.
Exactly. Yes.
Industries are using dynamometers, practical industries. Actually, dynamometers loading, there is a purpose. We visited some EV companies in Bangalore, where in Namrata we are having a campus, ATS company. They will be checking different vehicles. So how they are checking the vehicles is they have something called engine vehicle, IC engines for EVs. How they have research that dynamometer can Yes, that is giving the real time. Once animation is over, that is the practical use. They are using for even very high power, 100 kilowatt, 200 kilowatt. That is only they are having for even 100 kilowatt, 200 kilowatt. They are having that one side of the we can change the operating conditions. We can change the we can change the profile. We can change the profile.
Profile. Like maybe the vehicle is moving up. Maybe the vehicle is moving. Data acquisition system, like data we are extracting from the many other like maybe
just capture whatever is being said. These are 6 minutes brainstorming, so you can choose any of the things you take it up. And then the rest of the people go out ideas. Usually each person gets a chance to one idea per person. You don't think, you just say, keep on. And then at the end of the brainstorm, the whole thing is then you apply what you can say. These two seems to be most basic or most viable, so we take the next one. Go to the door and join. Okay. Yeah. Good. Thermal management is thermal is also
I don't know now. I don't know anything. How we can work on that.
Sensor, what is the sensor? Sensor. What is sensor?
I don't know.
I don't know current temperature.
sensor type of surrounding both internal and external.
Flatness is the thermometer. Flatness is the thermometer.
Temperature.
Those are the accurate meters. That is the name. Platinum resistant thermometers. Thermocouples. Thermistors.
Temperature. Whatever you're doing, everything comes under temperature. Okay.
Okay. Pressure sensors. Uneven. Uneven true stability sensor.
Incorporate the fault which is actually happening. Suppose I'm having a bearing failure. What actually happens in the
Barometric
machines,
pressure sensor.
how to imitate the fault. There's only data collection based on the quality data.
Quality data.
Quality data depends on how you are putting the fault, actual fault condition, and if I am creating the fault, whether I can feel the
Proper placement of
proper placing of the
instrument.
selection and placement.
Data storage management. Data pre-processing.
Distance and relation sensors. It's written, no? Some sensors written.
Automate data collection and quality as
So
well.
in 2 minutes, you are going to go to the board and at least write one solution.
So look for the solution of this.
We have to check theoretical data, simulated data, and hardware data. Compare simulation data, practical data. Experimental and practical. Simulation.
Simulation is from
Design.
software.
Software.
Experimental is from the lab experience.
Yes.
Real time is from the
Real time.
vehicle.
Different loading or not?
That is only. Dynamometer will give all practically.
Conditional to
I don't know, dynamometer load.
Emulate the load.
Full load, half load, like that.
Any speed which load your vehicle,
Whether it is matched up.
program it. How we are EV planes or highways.
Any load cycle.
Yes, that I can program it. Unprogram it. Time duration and speed up. It will work accordingly.
Before testing, check the quality of the meters. How to check the quality of the meters?
we have some
That is written. We'll say later. Then our latest digital twin approach for data incorporating hardware and software. That is called digital.
data collection for different speeds also.
That is
Different
speed
loads.
torque mobile. Speed
Different
torque.
load, load is
Load is
different.
over.
Load will be different, but your speed is also different. So the load may be given at
Temperature
Load
conditions.
profile which is speed torque
So
profile.
already different temperature conditions.
Temperature, speed torque profiles. It's over.
So ours is over. Three writes that.
No, I cannot write it. My handwriting is lost.
Sir will tell you. Writing is good. Otherwise, sir will.
my rating is good. Nobody will write it.
Madam will come, sir. 1:1 is
Students, you please proceed.
explanation 1:1 email activity. That's good.
So it's a time to showcase your talent.
అలాంటివి వచ్చిన ఇంకా మాట్లాడు
నేనేమనలేదు, మీరు నేనేమనలేదు. కొంచెం పెద్దగా రండి.
Madam, write big one.
Big size.
Madam, write big size. It's not visible.
So as we are
Use gesture, madam.
Bandwidth students, Bandwidth students, not
Madam, use gesture. Increase, madam.
increase the size and
Erase. అంటే ఇక్కడికే కనిపించట్లేదు కదా, అక్కడ కనిపించదు, లాస్ట్ కనిపించాలి కదా.
ఇలా రండి. యాక్చువల్లీ పెన్ మార్కర్ కింది ఇలా రాయండి. పెన్ ఇలా రాయండి.
మేడం యూజ్ డెస్క్టాప్. మీరు అది మళ్ళీ రేపు మీరే రాయాలి, దాని మీద వాడాల్సింది మీరే, పిల్లలు కాదు. డార్క్ మార్కర్ సరే మార్కర్
So we are going to look into the solutions in a minute. So we will see how this goes. So we will take a group picture in front of your board at the end of this session, okay, as a memory.
Madam, data collection, technical solution. Technical solution.
Okay, last 1 minute, and then we are going to sit down and debrief or kind of discuss some of the solutions that is available in literature. So it's not working, you can borrow from the So you may have to loan your marker sketch.
It is also like that.
Right? That's fine. Okay, please settle down. You can sit wherever you want. You can sit with your group or you can come back to your original position.
On the right hand side, we probably have some solutions for solving the problem of feature extraction and how to decide on what features, right? So I am not going to debrief this because that is not my intention. We probably it's good to do it casually. We can do it, but I am not going to do that now. What I am going to do is I am going to present to you what is available in literature. Okay. So when it comes to the problem of how to generate data from simulation or from experimental test bench that is close to real world, the solution that researchers around the world are trying for is what we call as a digital twin. Okay, so therein lies your opportunity as a researcher. So current research of digital twin for predictive maintenance is at its initial stage. So if you have started your PhD or if you are in the first year, first 2 years, you can explore this field aggressively. For those of you that are in masters or about thinking about higher education, this is a field that will have immense opportunities. Okay? Actually, I have given a QR code for MATLAB website and they talk about digital twin, but the idea is you create a twin of your real world setup. Okay? A twin will behave exactly like the real world setup. And how do you create this twin? You have two different approaches. One is what we call as a multi-physics model. That means you try to model the thermal behavior, you try to model the electromagnetic behavior, you try to model the mechanical behavior, you try to model every domain, physical domain behavior in single model. Okay, that is what we call as a multi-physics simulation. A commercial tool like ANSYS, MATLAB, they all have these capabilities to develop multi-physics models. Okay, so that is one approach. But the approach that is becoming more popular in recent times is actually use of generative models. Okay, so if you have heard of ChatGPT, so generative predictive transformer, right? That is the GPT. So they are using generative transformer models to synthesize data that could be close to real world. Okay? So researchers are trying in both sides like multi-physics as well as in data-based techniques, and probably there are some researchers trying to combine them both. They are developing a model which is a multi-physics model. It gives you some data and then you use it to generate more data like that. So the field itself is still nascent. It's just a few years, and therefore this is a great opportunity for you all if you want to pursue research in this domain. There are some excellent problems where not just you but the entire world has the knowledge gap, and we just need people like you to find some solutions. Okay? So this is one opportunity. The second problem we have is how can we minimize the impacts of feature selection, right? So the problem is how do we mitigate, right? That's the question. And the solution that researchers have come up with is something very interesting. They say, why should we do feature selection? Why can't we have a model that chooses the features? So the idea is people have started choosing methods. I will be presenting about one of the techniques in tomorrow's session. It's called convolutional neural network. There is also a technique called long short-term memory based algorithm. There are also generative models that are being used. Okay, transformer model especially is very gaining popularity in these aspects. So what we are trying to do is we are trying to capture raw data, feed it. We don't bother about feature extraction. Reason being, we think that that model can identify features which are not even visible to us, which we cannot even conceive. The model is going to conceive. Because it's only data, as engineers we will never be willing to add voltage and current, but that model will not hesitate to do that. Okay, and probably that might result in better accuracy or better performance at in lower training time. Okay, so there are two complex problems, and research around the world is taking paths that are just starting. Okay, digital twin is one domain, and using deep learning typically, or specialized networks or specialized algorithms for overcoming the problem of feature selection. Okay. So these are the two broad themes that, from a technical perspective, research has started. Okay. So if you are keen on pursuing research in this field, which I would strongly encourage you to, you are welcome to look into these aspects. Now, the good thing about researching on these fields is they are transferable skills, as we will call it in an industry. So if you learn how to build a digital twin for an electric motor used in an EV, you can be employed by any company that wants you to build a digital twin. You just have to put in the effort to build a specific digital twin for a particular company. Likewise, if you are working on CNN and LSTM algorithms, you may be using it for any particular application later on. It need not be only condition monitoring. So these skills are extremely transferable, and therefore there are lots of opportunities in this domain. Okay? One of the reasons I didn't want to debrief is because this is the first time I see you all are even doing a brainstorming activity. So that is why I did not debrief, but typically at the end of the brainstorming there will be a debriefing meeting. Okay. Okay. So some of the points that came up. How can we address knowledge gap? I mean, we are like any ANN algorithm that is to be trained, right? We have to continuously update ourselves. Our weights and biases have to be continuously updated. So there is no other mechanism. So continuous learning and constant input is the only way you can minimize that knowledge gap. Knowledge gap will always exist. Another way is to collaborate, right? So if you are good at something and if your friend is good at something else, then you kind of work together to minimize the gap. So those are things that you will have to explore. These are not technical issues. These are some things that you will have to look into as an individual, as a society, as an organization, all those things. How can we mitigate expenses? I think this forum, the Gyan workshop, has brought in researchers from all around the country pretty much, right? And in fact, if you include me, from many parts of the world as well. And now we have made a connection. So the best way to mitigate expense around the world is researchers, generally what they do is they collaborate based on the facilities they have easy access to. So for example, NIT Warangal has a center of excellence where they can machine and create that eccentric bushing for you. Okay? So it will be much cheaper for you to travel from Hyderabad to NIT Warangal than to actually set it up in your own institution, if you think about it. Okay? So that is the idea. So you have a setup here, you can collect data. And one thing that I want you to remind you all is most of our undergraduate machines lab already have enough equipment for you to start working with traditional machines. May not be permanent magnet machines, but at least traditional machines like induction motor. Many of the older labs will have an open winding induction motor. You can tap into different taps and you can say create an asymmetry and check. Right? Your modern oscilloscopes have storage capabilities. Your modern microcontrollers, which are extremely low cost, are good enough to do A to D conversion, store data. Okay? So you have many facilities already available at your hand. It is just a matter of you trying to think outside of the traditional boundaries and come up with test benches. And the thing is, we should not think like an academic person when it comes to experimentation. We have to think like an industry person. That resource is time constrained. So if you can do your experiment in 3 hours, All you have to do is seek permission to have that facility for 3 hours. Right? So it's up to you to convince whoever that needs to have access to a particular test equipment for 3 hours. Okay? So it is not, so what I'm trying to say is, it is not as bad as you think. You already have access to many of these equipment. And if you know, say for example, if you are from NIT Warangal, if you know another NIT or another IIT has a PMSM motor drive, as I said, it will cost you much lower to go to that institute, get the data and come back. Than to invest in your own dedicated setup. And this is true for private institutions too. It's not only for government institutions, right? You don't have to rely. So the answer is collaborate. And this is strongly encouraged around the world. It's not a new thing that I'm saying. Government grants are given like that, when they encourage collaboration between researchers. Government does not want the same test setup to be replicated in every institution. Okay? They want one center where people can go, collect data, and then people can use it. So that is the intention. So in summary, we are nearing the end. I am giving some time because I want to take group photos with these boards. In summary, in every step of machine learning algorithm or method, we will face a challenge. Data collection, data processing, feature selection, hyperparameter tuning, like that. There is lots of unknowns, uncertainties to overcome. But in every challenge, there is an opportunity. So if you are willing, there is a way. Right? So it's a matter of your will. And just to recollect, what is PhD? So you are either doing it or you have done it. So you just have to repeat it. Right? So with that I will stop this session. We can casually debrief and take some pictures. And then we will meet again tomorrow morning around 9. Does that sound good? I have actually shared research articles and QR codes. I encourage you to read the introduction section of that research article I shared. That gives you an idea of how trend is going towards mitigating features or collecting data like that, especially with respect to a data-based, machine learning, algorithm-based approaches. Okay? So you please read through the introduction section. You don't have to go through the entire paper. That will give you a very good idea of what you should explore as a researcher. Okay? Thank you so much.